quickly as possible. So, imaginary numbers, we've talked about imaginary numbers before, briefly. We've talked about it in Algebra 2, and now we're going to talk about it in a little more depth. Now, what is an imaginary number? An imaginary number is a number, is when it's inside a square root. A negative 1 would be equal to I. Okay? So, it's going to give you that information. So here's what they tell you in the little brown box on 3 to 40. I squared is equal to negative 1. Okay? Regular I is going to be equal to the square root of negative 1. Okay? So those are our two things that are very important to understand. And so once you have that I, it just makes it imaginary. It makes part of the information an imaginary figure. Okay? And one definition they give you is an imaginary number contains the imaginary unit, either a pure imaginary number or the sum of a real number. Okay? So that's important just to remember as you go. So when you have found imaginary numbers, you will use the quadratic formula to do so. So if they gave us an equation of x squared plus x plus 1 equals 0. So we would have to use the quadratic equation, which you should remember from our past lessons, which is what? Negative b plus or minus the square root of b squared plus 4ac all over 2a. All right? So that's our initial equation. Sorry, it's minus. Minus. Okay? All right, so we have this information. Now we got to look for the a, b, and c. Well, what is the a, b, and c? The coefficient in front of the x is the a. The letter in front of the b is the second one and third. Okay? So b and c. So we plug it in. So it's going to be negative 1 plus or minus the square root of 1 squared minus 4, 1, 1, all over 2 times 1. That makes it pretty easy to do. So now when we simplify this, 1 minus 4 is going to give me a negative 3. So I'm left with negative 1 plus or minus the square root of negative 3 over 2. So what does that become? So how do I simplify this? I can't leave a negative inside there. So what does this really become? Negative 1 plus or minus the square root of 3i. So the I comes outside of it all over 2. Okay? So that's what your answer becomes. All right? All right? Any questions on that and how you would solve that? So you can leave it like this. You could also split it up. The book has it split up, so it would be your answers would be negative 1/2 plus square root of 3 over 2i, and negative 1/2 minus square root of 3 over 2i. So you have two answers from one derivation. All right? Does that make sense to everybody? So what's a complex number? So this is an imaginary number. We all understand where that comes from. What is a complex number? A complex number is when you take a whole number or a real number and you add an imaginary number to it. So like a generic standard form of a complex number is going to be a plus bi. Okay? Because it has a whole or a real number and it has a imaginary number. All right, any questions on that? All right, good. So keep in mind as we begin this process talking about complex numbers and so on, it will come in handy here. Now, here's what they do, okay, and what you have to do, all right? So they want you to be able to solve for imaginary numbers quickly, all right? So far in review for this lesson specifically, quadratic formula, complex numbers, imaginary numbers equal to square root of negative 1, I, square root of 2 is negative 1. Now, let's think about this for a second. What would, if I wanted to make it I to the third power, what would it be? Well, think about this for a second. What is that broke down to? I and I squared and I, which would make it negative I overall, because this becomes -1 and this becomes I. Does that make sense to everybody? All right, so if I were to list them, I to the 4th power. So what would I to the 4th power be broke down to? And by the way, this is fairly straightforward because it's going to be I squared, which is going to give me -1, -1, which is going to give me +1. All right, so let's say it's I to the 5th power. Well, again, here we go. What does that break down to? I to the 4th, I to the 1st, which essentially is a positive I. And that's how you would go from there. All right, thank you. We'll come back to this in about 3 seconds. One of these methods. So, I, just for those, is square root of -1. I squared is -1. I cubed is going to be -I. I to the 4th is going to be 1. So what you do is you just break down whatever that exponent is into methods that you can do. So for example, I to the 8th power. What can this be broken down to? I to the 4th, I to the 4th. Well, what do we know I to the 4th is? 1 times 1 equals 1. So it's a very simple way to solve this problem. So, good example. We are going to try one, all right? A bigger one. All right, so the key ones you need to remember are these right here. And I to the 5th, which we already did, which would give me a positive I. So, these are the 5 you need to memorize. I squared, I3, I4, I5. You memorize those, you will be able to do any problem. So if we have I to the 63rd power, well, what power do we want to get rid of? It's close to I to the 4th power. 4 goes into 65, how many times? 63, how many times? So 4 goes into 63, how many times? 1, so 4, 23, all right, 15, so 20. So we're left with a remainder of 3, right? So now listen carefully. 15 to the 4th power. 15 to the 4th power. So 1 times 1 times 1 times 1 times 1. 15 times. So really, what is that? It's 1. And we're left with an I to the 3rd power. Does that make sense to everybody? So, because the remainder is 3, so what's the I? -I. So what's my answer, class? The answer is I to the 63rd power is -I. And that's your answer, that's your final answer. How do I show that? This is I to the 4th, how many times? 15 times. Then this is going to be I to the 3rd, so that's left, gives me a -I, and this gives me 1. 1 times -I is -I. Okay? So all you're doing is you're going to find whatever number 1, 2, 3, 4, 5, that can divisible go into there to help you be able to solve it as quickly and efficiently as possible. So that's how you would solve those bigger numbers. All right? Now, the last thing you need to remember is that with your complex numbers, these complex numbers can be used as, you can move them around. In other words, you can communicate them using the commutative property. You can communicate them in a different manner. So that being said, this is how they give you some examples. All right. So one of the examples they will give you is one that looks like this: 2 plus 4i plus 5 plus 7i. Now, what do we need to do in order to combine these and be able to get them simplified? Well, what do? We can rearrange them. So 2 plus 5 can go into one parentheses. And in this parentheses over here, it's going to be 4i plus 7i. So now what do? Well, 2 plus 5 is, what's your answer? 2 plus 5 is 7. 4, now here, we can combine these, 4i and 7i. What does that give you? A negative 3i. And that would be simplified form. What you need to remember is that when you have this information, you can communicate, the commutative property works across these lines. Both sides, add 3x to both sides. We're left with 6 equals 3x plus 7ix. Then we're going to distribute out your x, so you're left with 3 plus 7ix equals 6. Now, we have to bring this over, divide both sides by 3i, this, 7i, so that we can get x by itself. X equals 6 over 3 plus 7i. Now, that's not finished, and in order to finish the problem, you have to bring this in from the bottom up. And in order to bring it up, you need to do subtraction, the opposite. So when you do that, what are you left with? All right, the top is obviously going to be 6 times 3, which is 18, minus 42i, correct? So we distributed that through. Then on the bottom, it's going to be 3, 9, and then negative 21i plus 21i minus 49i squared. So once you get that, now you're in working order and you can finalize your problem. All right, you can finalize that problem. How do you finalize that problem? Well, I'm going to bring this up over here, make it easier for me so I don't have to kneel so long. So you're left with 18 minus 42i all over 9 minus, and the two middle ones cancel, right? These cancel out. Minus, and i squared is negative 1. So 9 plus 49, which essentially is what? 9 plus 49 is 58. Good. 58. So we're left with take out 9 minus 21i, and I'll explain that in a second, over 58. 2 goes into 58 how many times? And you're left with 9 minus 21i over 29. And that would be your final answer. All right, so x equals that. Why can you? Because you cannot leave an I in the basement. You can't leave I in the bottom of an equation. The reason you can't is because it is like a square root. You can't leave a square root in the basement. You can't leave an I in the basement. So those are the two things, the key components you must remember in doing this lesson. Thanks.